So in this video we will see Macaulay's method. So in the previous double integration method there was only one load, that's why it was easy to solve. But here we have 5 kilonewton, 7 kilonewton and 9 kilonewton at three different locations. So to solve this we have to, for double integration methods, we have to take uh, variable x in between these two forces and here also. So three different forces we have to take. We will get 6 equation of slope and deflection, and then we have to take the boundary conditions at these locations, and it will be very hectic to solve. To solve this problem we use Macaulay's method, in which we directly take variable x such that all the three forces are there in the moment equation. So if we take moment at x up to here, from this at x equal to 0, we'll get this equation minus 5x minus 7 into x minus 1. So at this location the moment due to 7 kilonewton will be 7 into this particular distance, which is x minus 1. Similarly minus 9 into the distance this, so it is x minus 3. 1 plus 2 is 3. We do not have to open these brackets, and we have to solve this exactly similar to the double integration method without opening these brackets. Now if we apply the equation ei d square y by dx square, and that will be equal to moment, so this is mx. Now if we integrate this, you see here I have integrated this to equation twice. First I have integrated once, so I'll get ei theta. So integrate each term individually plus c1. So do not open this bracket, and again you integrate it one more time, ei y, from theta it will become y. Integrate each term separately and do not open the bracket. C1x plus C2x will be there. Now for boundary condition, you see we know that at x equals to L, means x equals to 6, 1 plus 2 plus 3 is 6, deflection and slope will be 0. So from this, if we put x equal to 6 and theta and y equal to 0, we get these two equation where x equal to 6. So 6 here x minus 1 will be 5, x minus 3 will be 3 plus c1. Similarly here c1 into 6 plus c2, and all three terms are this 6, 5 and 3, 6 minus 3, 3. So we will get c1 from this equation. We'll use c1 here, and then we calculate c2. So c1 and c2 are calculated from this, and these two c1 c2 value we have to keep in these two equations. So we'll get a final equation of theta and y. Now you see, if we are calculating slope and deflection, so between a and b, if we are calculating slope and deflection, then we have to use these two equations, where you see here first term for theta equation I have used. These two terms I have neglected, because if we keep x equal to 0 to 1, these two terms will be negative, so we do not have to use these two terms. For y also, only first term we have to use. These two terms we have to neglect here. If we put x less than 1, from 0 to 1, these two terms will be negative. We have to ignore these two terms, only this plus c1 x plus c2. And if we are calculating slope and deflection between b to c, then in between c to b we have to calculate ei theta by considering these two terms only. We have to ignore these terms, because x minus 3 will be negative when x is in between b to c. So first and second terms we have to consider, and then plus c1, here it is plus sign. Similarly ei y, we have to consider these two terms only, and we have to neglect these terms, because in between b to c this x minus 3 will be negative, plus c1x plus c2. So c1 c2 will get from boundary condition, and with the different regions we have to use different formulas. We have to make sure that we do not open these brackets while solving the integrations. And for between c to d we have to use this generalized equation, because all three terms are applying moment at between c to d, and deflection is due to all three loads. So we have to use this general equation between c to d. So at different location we have to use different equation. ignore these two terms between b and c, and ignore both these terms 7 9, both these terms we have to ignore between a to b. So this is how we calculate in Macaulay's method. It is exactly same as double integration method, but we just normalize it with all the terms, all the loads in single equations, and we use double integration. So thank you for watching this video, and see you in the next video.